Okay, good morning. Thank you very much to Matt for the introduction and for the opportunity to be here today. This is a wonderful forum bringing together stakeholders from across the water sector to deal with what is one of the great challenges of the coming decades, understanding the impacts of climate change on water resources, broadly speaking. So in the next 20 minutes or so, I want to focus my messages around three key messages that I think are important to try and frame discussions for the rest of the day, drawing on insights and importance in terms of the diversity of impacts that climate change presents to the water sector, the lessons that we've taken from things like integrated catchment management, from the Water Framework Directive, and how they can add value to how we think about climate change and the response to climate change. The first key message I want to impart is that climate change is not just a threat for the future. It is happening here and it's happening now, and we need to begin to adapt to climate change. We can see very clearly when we look at global temperature observations, that's the graph on the right-hand side, we can see that 2023 was a particularly remarkable year. Not just was it the warmest year on record, but for months from June all the way through to the end of the year, it was really head and shoulders above any other year in terms of global mean temperature. And we're likely to surpass that in 2024. We're odds on, 99% chance now that 2024 will exceed 2023 as the warmest year on record. And when it comes to climate change, that global warming, that increase in global temperatures is changing the hydrological cycle. It's amplifying it, it's making it more extreme, particularly with things like heavy rainfall events. And we have seen over the last couple of months the occurrence of major flood events in different parts of Europe, and in each of those flood events, the fingerprints of climate change are very evident. If we go back to September and Storm Boris, Central European flooding, affecting countries like Poland, Czech Republic, Austria. Really warm surface temperatures, ocean temperatures in the Mediterranean, warmest on record, made extremely more likely, far more likely by climate change, provided a pool of really warm water, easily advected or inserted into the atmosphere. Warmer temperatures increase the water holding capacity of the atmosphere. So you see with warming temperatures, more heavy rainfall events. And additionally, we saw a low-pressure system, the storm, getting cut off and blocked, stuck in place, delivering huge amounts of rainfall over the period of a day or two. And some argue that even that cut-off lows, those storms getting stuck in place, is due to warming in the Arctic. I won't go into the details, but can expand them if you so wish. So there are three fingerprints in the Central European floods in September. Fast forward to October and the dramatic scenes that you saw from Spain and the Valencia region, those three same fingerprints are evident within that event. Yes, weather events happen and floods happen and droughts happen, but climate change is amplifying them, increasing the nature of the extreme event and the consequences for nature, society, the economy, environment, etc. Here in Spain, again, warm ocean surface temperatures, advecting moisture into the atmosphere, warmer atmosphere holding more moisture, more heavy rainfall events, and a low-pressure storm stuck in place for a prolonged period of time. So the climate impacts that we talked about just 10 years ago, I remember giving talks, are here, we can see them, and we can discern them in our observations. And it's not just out there, it's also here. We've seen last year, 2023, October, the floods in Middleton and County Cork, and we've done the first attribution study in Ireland where we can show clearly that climate change through emissions of greenhouse gases is increasing the likelihood of floods like the Middleton flood. We saw the devastation that imparts for people, for health and well-being, for livelihoods, the costs, etc. We know the impacts. But we know from this kind of analysis that climate change, through warming temperatures, has doubled the likelihood of the two-day rainfall extremes that triggered this flood event. And rainfall intensity is increased by 13% in this particular catchment. So we see the impacts in individual flood events. And we're also seeing the signal of climate change in our rainfall records. Over the last number of years, we've been involved in collating long-term records of rainfall and temperature in Ireland, with Med Éireann, quality assuring them, and using them to see if we can discern this fingerprint of climate change. And in our heavy rainfall events, the signal of change is clear. Up on the maps on the top right are just 3 indicators of heavy rainfall: intensity and the proportion of the annual totals from heavy rainfall days. And in each of those, where you see the blue triangle, they're increasing, and where you see it's filled in, it's not white, that's where we can show clear evidence of a link to warming global temperatures. And we're seeing an increase in heavy rainfall events across all of those stations, like Folk Mills in Wexford, 8% increase in heavy rainfall for every 1 degree rise in global temperature. That's exactly consistent with physical understanding. The Clausius-Clapeyron relationship: for every 1 degree rise in temperature, we expect a 7 to 8% increase in heavy rainfall. We're seeing that in our records and our heavy rainfall events. And it's propagating as well through to temperature change, even clearer in temperatures. So again, these are temperature records that we can look at and see how is Irish temperature changing relative to globally, and what is the role of anthropogenic, human-driven climate change. And across these long-term stations, particularly those ones in red, in Birr, Dublin, Armagh, and Malin-Head, we're warming at a rate that's faster than global average temperature. So, for example, Phoenix Park in Dublin is warming at a rate of 1.14 degrees for every 1 degree rise in global temperature. Other parts of the country a little bit below, but on average, what we're seeing in Ireland is very consistent with what's happening globally. If you were to live at the end of the 1800s, the temperatures that you're seeing on a seasonal and annual basis today would be either unusual or entirely unfamiliar to you if you lived in early industrial Ireland. And these are propagating through to the hydrological cycle. This map here shows the trend, increasing or decreasing, in the magnitude of floods across Ireland. And I want to draw your attention to the Shannon Basin, where you see those large increasing blue triangles. The annual maximum flood event is increasing. And we've been working to try and understand the drivers of that increase. And in the middle set of plots, just for 3 records, we're able to show that it's rainfall change that is driving predominantly the increases in flooding in the Shannon catchment. And when we dig into the rainfall that's so important, it's the rainfall over the previous 30 days that define antecedent conditions, wet up the catchment. You can see the increases in the number of heavy rainfall events within the previous 30 days. So even within floods, the increase in heavy rainfall events is precipitating or propagating through to increasing trends in floods. And recently, we've been developing a reference hydrometric network for Ireland, high-quality river flow gauges from across the country, using them to extend our records back to see how seasonal river flows, these are all catchments across Ireland, are changing. The white triangles that you see there, the blue white triangles, are increasing trends beyond the range of climate variability. These are significant increasing trends in winter rainfall, or winter river flow, particularly in the east and the west and the northwest of the country. In summer, there are widespread decreases. In autumn, increases in river flow in the north. So even our average river flows are changing on seasonal and annual basis. So that's my first message. Climate change is happening. It's here. It's not out there somewhere else, and it's not just in the future. The second key message is that water needs to be at the core of our national climate objectives of achieving a climate-resilient Ireland. For me, much of the impacts of climate change will be experienced through too much, too little water, and how we manage that. In addition, as an island, things like sea level rise and storms. But for this conversation, and more broadly, for realising a climate-resilient Ireland, water needs to be at the core of that objective. And we need to start by recognising we're not commencing or starting that journey from an ideal position. Challenges in terms of water quality declines, challenges in terms of infrastructure, challenges in terms of nature, aquatic ecosystems that we'll hear much more about in the panel discussion. So we need to recognise our vulnerability and exposure. We can look at recent extremes, think back to the 2018 drought and reflect upon it. You're the experts on the front line. What was the impact of that drought event for what you do in your sector, your area of expertise, or your locality? Because when we look at historical records of drought, over on the right-hand side, all of those letters are different rainfall stations across Ireland, showing the occurrence of extreme and severe droughts, or those dark brown colours, Where they go across that graph, they have an island-wide effect. They're droughts that occurred right across the island. We call it the DNA of Irish drought. When we put 2018 in there, it doesn't stand out as that remarkable. When we go back and look into that record, there are potentially far more damaging droughts that have happened in the not-too-distant past, and there's no reason why they can't occur again, even in the absence of climate change. These are just zooming into some of those drought-rich periods on the right-hand side. What would happen, for example, if the drought conditions between 1932 and 1935, these ones here, were to happen again? They're multi-seasonal droughts that are occurring all the way across the country. Similarly, if the 1850s was to happen again, almost 4 or 5 years where there's persistent in and out of drought over long periods of time. These are events that have happened in the record, part of natural variability, but we've changed a lot since then in terms of demands on water, pressures on water. What if they were to happen again? And when we look to the future, climate change is likely to impact on these kind of droughts through two main ways: increases in temperature and evapotranspiration losses, and also decreases in rainfall. We've been looking in climate model projections and looking at how droughts in the future are likely to change. And this is an assessment, one such assessment. The top row are seasonal droughts under current conditions. The middle row of maps is under a medium emission scenario into the future, and the bottom row is under a high emissions scenario. Particularly for a high emissions scenario, we see increases in drought in spring and summer, so increasing longer duration droughts, similar to 2018 spring-summer event, becoming more frequent and more widespread, particularly in the east and the south of the country. When we look at the same kind of analysis at our rivers across Ireland and looking at low flows, really important for aquatic life, really important for water quality, for water resource provision. Low flows for all of those catchments across the country. We plot all the results here. The orange and the red are for medium and high emission scenarios. And across all of those catchments, they're showing reductions in low flows of becoming more extreme by, on average, 20 to 25%, some catchments even up to 40, 50%. The key message from this graph is that the blue line on that shows much more modest reductions if we reduce greenhouse gas emissions. If we are successful at meeting the Paris agreements, realizing that we don't keep global temperature rise to any more than 2 degrees Celsius, we're already at 1.3 degrees. So we have a lot of work to do. These impacts, extremes, floods, droughts, impact on people. There are people today going to talk about the impacts of floods on health and extend that out to health and well-being. We know the impacts on infrastructure, the insured losses. What about the non-insured losses? The impacts on people's psychological well-being, livelihoods, all of these things. So we need to really think about people and place people and nature at the center of our thinking on climate change. Just like with droughts, flood events are likely to increase in future. This is another piece of research, again funded by the Environmental Protection Agency and the Water Futures Project. For all those catchments on the right-hand side, you're showing increases in the magnitude of a flood we'd expect to occur once every 20 years. So a clear signal to increases in floods. Depends on the individual catchment, just how much. And again, the more emissions we emit over the coming decades, the greater the impacts on floods. So the third key message is that we are making progress. We have nationally now our sectoral adaptation plans. They're being updated. Water and flooding is part of those. They're being updated this year, republished, relaunched. So there's a lot of work going on, but we also have a long way to go. Local authorities, so important to climate change adaptation, have their climate action plans, and greenhouse gas emissions reduction and adapting to the impacts of climate change are part of climate action. But a key challenge we have, even in the water sector, and Matt outlined at the start, is that we often have conflicting priorities, depending on what sector that we're interested in. If we think about what climate resilience means, it can mean different things to different parts of even the water sector, never mind outside of that, which is impacts for water. So it's really important that we start to develop shared goals in order to avoid conflicting priorities to realise a climate resilient Ireland. And I want to draw upon some recent research that we're doing as part of a project for the EPA called ORICA, Operationalising Climate Resilience, where we've been doing interviews with practitioners, policymakers, stakeholders within the water sector, asking them, for example, what does resilience mean to you? And this is just a snapshot of some of the outcomes. It means very different things to different people. For some, it has an uncertain meaning. For others, it should have a social focus. For others, it's about maintaining the status quo. For others, it's about infrastructure. For others, it's about ecosystems. Others, it's an economic focus. And lots recognize conflicting priorities. So again, if anything comes from today in these discussions of all the different stakeholders in the room, it's how do we move towards shared values? In terms of operationalizing climate resilience, taking climate action in the water sector, these are some of the challenges that were identified across the sector. Things like challenges in implementation because of a need for more formal frameworks and guidelines for adaptation in the water sector. The need for avoiding conflicting priorities and the recognition that this is a sector that is already stretched in terms of the Water Framework Directive. People being overstretched, needing to learn, needing to have buy-in politically and additional resources are some of the challenges that are identified for progressing climate action. And then final question we asked was, what would transformative change look like to you as individuals working in the water sector? What would be a big change that would make investing and implementing climate action more efficient? And there's lots here, but I think it's really important to dwell on what the key messages are. Thinking about putting people and nature at the center of decision making, so we call it justice approach. Thinking about additional funding and making sure funding is available. I sit on the National Adaptation Committee advising government on implementation of adaptation, and a key thing we keep coming back to is funding in order to implement the plans and strategies that are there. Developing a shared vision and avoiding conflicting priorities and recognizing common values and goals, and particularly having political leadership. In a year of an election, placing water, placing climate more center in our political decision-making and political buy-in is crucial. And especially for today, having a catchment focus is recognized as being potentially transformative in integrating multiple pressures and common goals. So that's where I'm going to leave it. There are experts on the front line that are going to be in the discussion in this panel and throughout the day, and you're all sitting around the tables, so I hope there are good discussions. But to sum up, my three key messages to frame today is that climate change is not just a future threat, it's happening now, and we need to adapt. We are vulnerable and exposed to climate change impacts. Water needs to be at the core of our national climate objective of a climate-resilient Ireland, and foundations are being laid. Good work is happening. But we do have a long way to go. We need to confront the challenges that we're experiencing, the meaning and shared vision of resilience, avoiding conflicting priorities, capacity building and political buy-in, incentivizing collaboration, avoiding our silos, and developing those shared values. So thank you.